Hello, everyone. Today I am explain about what is hardening and what is annealing. Hardening and annealing are two different heat treatment processes used to modify the properties of metals and alloys. Hardening. Purpose. Hardening is a heat treatment process used to increase the hardness and strength of a metal or alloy. Procedure. The metal is heated to a high temperature and then rapidly cooled, often by quenching it in water, oil, or other cooling mediums. Effect. The rapid cooling traps the atoms in a specific arrangement, making the material stronger but also more brittle. Applications. Hardening is used in applications where high strength and wear resistance are essential, such as cutting tools, gears, and springs. Annealing. Purpose. Annealing is a heat treatment process used to soften a metal or alloy, improve its ductility, and reduce internal stresses. Procedure. The metal is heated to a specific temperature and then cooled slowly, usually by letting it cool in the furnace or burying it in a heat-insulating material. Effect. Slow cooling allows the atoms to rearrange themselves into a more stable structure, reducing hardness and increasing ductility. Applications. Annealing is used when a metal needs to be formed or shaped more easily, as well as to relieve internal stresses caused by prior processing. Let's discuss the uses of hardening and annealing in more detail. Uses of hardening. Tool and die making. Hardening is crucial for creating cutting tools, dies, and molds that require high wear resistance and toughness to withstand repeated use and pressure. Machine components. Many machine components, such as gears, shafts, and bearings, undergo hardening to enhance their strength and durability, ensuring smooth operation under heavy loads. Springs. Hardened springs maintain their shape and elasticity better, making them suitable for various applications like automotive suspension systems and industrial machinery. Metalworking tools. Hardened metalworking tools like drills, chisels, and punches can efficiently cut and shape other metals without wearing out quickly. Firearms and blades. Guns, knives, and swords are hardened to improve their cutting edge, strength, and resistance to wear and deformation. Uses of annealing. Forming and shaping. Annealing softens the metal, making it easier to bend, shape, or stamp into the desired form during manufacturing processes like rolling, forging, and pressing. Stress relief. After extensive mechanical work or welding, metals often have internal stresses. Annealing helps to relieve these stresses, reducing the risk of deformation or cracking. Electrical components. Annealing is used in the manufacturing of electrical wires and components, as it improves their conductivity and flexibility. Cold working. Some metals like copper and brass can become harder and more brittle during cold working. Annealing them restores their ductility, making them easier to work with. Recrystallization. Annealing promotes the formation of new, smaller crystals in the metal, improving its uniformity and overall mechanical properties. The effects of hardening and annealing on metals. Effect of hardening. Increased hardness. The primary effect of hardening is a significant increase in the hardness of the metal. Hardened metals can resist wear, abrasion, and indentation better than their original state. Enhanced strength. Hardening also leads to an improvement in the strength of the metal, making it more capable of withstanding external forces and loads without permanent deformation. Reduced ductility. While hardening improves strength and hardness, it often reduces the ductility of the metal. Ductility refers to the ability of a material to undergo plastic deformation without breaking. Hardened metals become more brittle and prone to fracture under excessive stress. Improved wear resistance. Hardened metals exhibit improved wear resistance, making them suitable for applications involving friction and abrasive forces. Decreased machinability. As hardness increases, the machinability of the metal decreases. It becomes more challenging to machine and shape hardened metals compared to softer ones. Effect of annealing. Softening. The primary effect of annealing is softening the metal, reducing its hardness and making it more malleable. Increased ductility. Annealing significantly increases the ductility of metals, making them easier to form, shape, and work with using various manufacturing processes. Stress relief. Annealing helps relieve internal stresses that may have accumulated in the metal due to prior manufacturing processes or welding. Improved machinability. Softened metals are easier to machine, allowing for faster and more efficient metalworking operations. Recrystallization. Annealing induces the growth of new, smaller crystals in the metal, which can lead to improved grain structure and mechanical properties. Summary. Hardening increases the strength and hardness of a metal by rapid cooling, while annealing softens the metal and improves its ductility by slow cooling. Both processes are essential in the manufacturing of various metal products, depending on the desired mechanical properties. Both hardening and annealing play critical roles in various industries, allowing manufacturers to tailor the properties of metals to meet specific requirements for different applications. By using these heat treatment processes strategically, engineers can achieve a wide range of desired material characteristics. Overall, hardening and annealing have opposite effects on the mechanical properties of metals. Hardening enhances hardness and strength at the expense of ductility, while annealing softens the metal and increases its ductility, making it more malleable and easier to work with. Manufacturers use these heat treatment processes strategically to achieve the desired material properties for specific applications. Thanks for watching, happy learning. Content is prepared by Chakra.